All right, problem number 4 for the 2024 AP free response questions. They always give you this little box of information. It basically says, like, simplify stuff. Okay, and again, the setup is always the same. The functions they give you differ. So here's g of x, here's h of x. Solve g of x equals 10 for values of x in the domain of g. So for part 1 here, I'm going to say e to the x plus 3 is supposed to equal 10. How do I solve for this? To get x out of the exponent, you need to get rid of the base e. So you natural log both sides. Natural log and e cancel out. It gives me x plus 3 equals the natural log of 10. And then I subtract 3. This is a no calculator problem, so that's how I leave my answer. Solve h of x equals pi over 4. So arc sine, that's also known as inverse sine, of x over 2 is equal to pi over 4. How do I get rid of an arc sine? I sine both sides. Take the sine of both sides. That leaves me with x over 2 equals, what's the sine of pi over 4? That's radical 2 over 2. Multiply by 2 to solve for x. X equals radical 2. Part B, you're always condensing a log, and then for the first part, and then you're always working with trig identities for the second part. So part I says rewrite j of x as a single log base 10 without any negative exponents, and you should just have log base 10 of an expression. All right, so to start, remember, if there are numbers in front of the logarithm, which there's only one right here, that becomes an exponent. So this is log base 10 of 8x to the 5th plus log base 10 of 2x squared minus log base 10 of x to the 9th. And then any logarithm that is positive or has a plus in front of it, when we condense this into a single logarithm, that expression goes in the top. So 8x to the 5th times 2x squared. Anything that's being subtracted winds up in the denominator. And then you have to simplify this. They tell us that up here. Unless otherwise specified, combine terms using algebraic methods for things like this. So you have to simplify. So this is log base 10 of 16, 8 times 2. Add your exponents, x to the 7th over x to the 9th. So x to the 7th over x to the 9th leaves you with x squared in the denominator. So this is how far you have to simplify that. Part 2, rewrite k of x as a single term involving tan x. So let's take a look at k of x. So k of x is equal to 1 minus sine squared is cosine squared x over sine x. Instead of times secant, let's make it 1 over cosine x. That allows us to cancel out a cosine and a cosine in the top. Leaves me with cosine x over sine x. Now, that is cotangent x, but it says a term involving tangent x, so 1 over tangent x. So be careful on that one. We normally would leave it as cotangent x with the work we did this year, but they want it in terms of tangent. All right, and our last problem here, this one's usually worth 2 points. You get a point for the first step and then a point for solving it. So find all values in the domain of M that yield an output of 0. That just means set this thing equal to 0. Okay, I want to get rid of this inverse cosine, so I'm going to do that by taking the cosine of both sides. What is the cosine of 0? Cosine of 0 is 1. Okay, now solve for this. When is tangent equal to 1? That could be when 2x equals pi over 4, or in quadrant 3, 5 pi over 4. Now remember, both of those need a plus 2 pi k, where k is an integer. So x could equal, when you divide by 2, pi over 8 plus, divide that by 2, pi k, where k is an integer. Or x could equal 5 pi over 8 plus pi k, where k is an integer. An alternative is to say 2x equals pi over 4 plus pi k, because pi is the period for tangent. And then when you divide by 2, it could also just be pi over 8 plus pi over 2k. But I think you can give these two separate solutions and still get credit for that, because that is mathematically correct as well. All right, that finishes problem number 4 for 2024 test.